Have you ever wondered how the planets in our solar system move in their orbits? It's a dance of celestial bodies, a ballet of cosmic proportions, choreographed by the laws of physics. This intricate spectacle has fascinated humanity for centuries, leading to the birth of astronomy. Among the architects of our understanding stands Johannes Kepler, a key figure who deciphered the secret steps of this cosmic dance. His revelations forever changed our perception of the universe. The answer lies in a groundbreaking discovery made by Johannes Kepler. Kepler's first law, also known as the law of ellipses, shifts our perspective about planetary motion. This law is a departure from the ancient belief that planets move in perfect circles. Instead, Johannes Kepler, a 17th-century astronomer, proposed that planets orbit the sun in paths shaped like ellipses. An ellipse, in simple terms, is an oval shape. Imagine stretching a circle from two opposite ends. You'd end up with an ellipse. That's the path our planet takes around the sun. This elliptical orbit means that the distance between a planet and the sun changes as the planet moves along its orbit. Kepler's first law was revolutionary. It challenged centuries-old beliefs and fundamentally changed our understanding of the universe. This law not only describes the motion of planets but also applies to other celestial bodies, including comets and asteroids. This law reveals that planets move in elliptical orbits, not perfect circles as once believed. Let's delve deeper into the intricacies of Kepler's first law. Now, you might recall that this law states that planets orbit the sun in paths called ellipses, with the sun at one focus. But what does this all mean? Let's break this down, starting with an ellipse. In simple terms, an ellipse is a flattened circle. It's like you took a perfect circle and squished it from the top and bottom or the sides. This squishing creates two focal points or foci within the ellipse. Now, in the context of Kepler's first law, one of these foci is the sun. But where is the other focus? Interestingly, it's just hanging out in space, not doing much of anything. Yes, you heard it right. One focus is occupied by the sun and the other remains empty. Let's move on to the concept of perihelion and aphelion. These are fancy terms for the closest and farthest points in a planet's orbit around the sun. When a planet is at the closest point in its orbit to the sun, it's at perihelion. It's like the planet is saying, "Hey sun, let's get a little cozy." But as with all good things, this cozy period doesn't last forever. The planet then starts moving away from the sun, heading towards the farthest point in its orbit, the aphelion. Here the planet seems to say, "All right sun, I need some space." What's fascinating is that the speed at which a planet travels also changes as it moves from perihelion to aphelion. The planet moves fastest at perihelion and slowest at aphelion. It's like the planet is rushing in for a high five at perihelion and then slowly backing away at aphelion. So to sum up, Kepler's first law tells us that planets orbit the sun in a squished circle or an ellipse, with the sun at one focus. The closest and farthest points in this orbit are the perihelion and aphelion, respectively. And throughout this orbital journey, the planet's speed changes. So the sun sits at one focus of the ellipse while the other remains empty. Now that we understand Kepler's first law, what does this mean for us? Well, this law revolutionized our understanding of the universe. Before Kepler, we thought planets moved in perfect circles around the sun. But with his first law, the idea of elliptical orbits came into play. This shift from circles to ellipses may seem small, but it has big implications. For one, it changes how we calculate the motion of planets. The elliptical paths mean that planets move faster when they're closer to the sun and slower when they're farther away. This is crucial information for astronomers trying to track and predict planetary motion. And it's not just about watching the skies, this law plays a pivotal role in space exploration. When we launch spacecraft, we need to know where our destination will be in the future, not just where it is now. Thanks to Kepler's first law, we can predict the orbits of planets and navigate our way through the cosmos. Furthermore, this law opens up a new perspective on the universe. It's a reminder that not everything revolves in perfect circles. There's an inherent beauty in these elliptical orbits, a subtle reminder of the universe's complex and captivating dance. Thanks to Kepler's first law, we have a better understanding of the universe's dance, a dance where planets trace an elegant ellipse rather than a perfect circle.